Hey, and welcome to the Plumbers of Data Science podcast. I'm your host, Andreas Kretz, and today is a topic that brings my blood to boil. It's data modeling and how people always talk about data modeling. Everybody's like, oh, data modeling is super important. It's so difficult. And people are sending out their courses like, oh, data modeling here. We're going to teach you data modeling. And yes, of course, it's something important, but people make a huge thing out of this, which I absolutely don't understand. I don't know how this can be such a big thing where people say it's super difficult and create hours and hours long courses. Here are a few things that you need, and that's why I think this is so simple. Let's start with it. Why is this so simple? There are only two things that matter here in the beginning, right? There are two things that matter. The first thing is the data, and then the second thing is the goals. If you know this, if you understand this, already almost everything is done. Really. Now, the data, why is the data important? You need to understand what format is the data coming in, what speed is the data coming in. And this already gives you an idea, okay, how can I store this? How is the data, or how does the data need to be written? Because not every database can support every speed, for instance, or every volume of data, or in terms of scalability, not every database can actually scale as much as your data might be, right? So these facts around the data, that is the first thing you need to look at. That is super simple. Get yourself a sheet, get an example data set, figure this out. That's the first thing. Of course, you need to keep in mind the acid theorem, atomicity, consistency, isolation, and durability, because you need to figure out, does my data storage actually support this, and how much support do I need there? That's the main thing. Like, first thing, data. The second thing is the goals, because the goals are going to tell you how is the data going to be queried, how is the data going to be worked with, because how the data is going to be worked with is going to tell you how the data needs to be retrieved and what the performance is going to be, how much of the data is going to be retrieved at once, and what kind of calculations are going to be done within the data store. Right? So that's something, I mean, this is not super difficult. This is something you can all do on a piece of paper or on a Google Doc, talk with people, figure this out, right? So, okay. Then what can you have? You could have, then afterwards, you need to do the actual data modeling, right? Although I would say this is already a part of it. If you have a relational database, how difficult is this? I mean, you're going to create tables and you're going to follow the normal forms, right? First, normal form, basically atomic attributes. Second, all attributes are actually dependent on the primary key, and the third one, that you don't have dependencies between the attributes. I mean, this is everything. You don't need more. Of course, you can have also other normal forms here. I think there's also a fourth one who nobody cares about. But if you have these three things, you understand primary key, foreign key constraints, you can create tables. That's it. It's not a big deal, right? You understand how's the data going to be stored, how's the data going to be queried. That's it. That's it. That is everything with relational. And then people say, oh, of course, then we need to do data modeling in a NoSQL database. Oh, man, this is the easiest thing ever. This is also super simple. NoSQL is oftentimes a lot easier even than with relational databases. But if you understand relational databases, that's it. You don't need more. Then you get to dimensional storage, right? Dimensional databases, data warehouses. Now, I don't know what's the problem is here. Learn the star schema with fact and dimensional tables, then figure out, okay, what's the dimension? What's going to be in the fact? And this is basically coming back to that relational modeling schema where you have like a primary and a foreign key, and that's it. That's it. Why are people making such a big thing out of this? You can train this on your own. You can get yourself a dataset from Kaggle. You can just try this out and then just maybe talk with somebody. That's it. It's not a big deal. This might be a big part of what we do as data engineers, right? But like time-wise, it's a big part, but actually skill-wise and doing it, it's not a big deal. You have to think a bit about it, but it's not like this is super difficult. If you keep in mind, okay, this is how my data looks, this is how my data is coming in, this is how the data is queried, and how people are going to work with it. And then, like, what else can you do? Oh, Now I'm having performance issues. Let's create some additional indices on the data. Wow. Big deal. So small rant here. I don't want to keep you long. I think this is something, it's not a big deal. I have 2 courses or actually 3 modeling courses in the academy, a super basic one. I think that already delivers you almost everything you need. We create a relational and a dimensional. These are like short courses, about an hour or so, but you will get everything there. And once you've done this, once you've seen this and you understand how this works, it's not a big deal. Like the amount of time I read this on social media and everybody wants data modeling. Oh, give me a break. Okay, so that's my rant for today. Maybe next time we talk about Python and data structures and algorithms, because everybody's like, we need this. All companies want this. We need to do Kaggle competition. And what exactly do I need? Okay, guys. See you next time. I hope this was fun for you. Let me know in the comments what you think. Is this a big deal, or am I like seeing this wrong? I like to hear your opinions. Send me a comment on the YouTube channel.